Keyboard Junior is alive. Greetings and welcome back to the lab, and welcome back to Musical Monday. I think it's time we finished populating this circuit board so we can get Junior up and running fully. I'm still waiting on parts, so I can't build the regular keyboard yet. I also am waiting on the revised version of this particular board, so best I can do right now is build this out, and I have an idea for an enhancement that would probably be the next circuit board, something that I can try. So let's see if we can get that all done in this episode. But rather than me bore you with filling out all of these, I'm just going to go ahead and do it off camera and come back to this, and then we can tune it and make sure everything is working properly, and then we'll go from there. So stay tuned. I'll be right back. I'm back. I'm not done. I realized a couple of things while I was working on this that need to be addressed. One, again, was the resistors. That's not new. Some of my 5% resistors are actually more accurate than my quote-unquote 1% resistors. But so I picked the best ones. I used my meter to actually go through the batch until I found something that was within, say, 2%, something like that, just to get it closer. And so this third oscillator, the E note, should be within 200 ohms of target. But it also occurs to me that even the 1K resistor for R1, that is off by a little bit, so that's affecting it too. So I put the 1K pot back in there. That would be this one right here. And we're going to go ahead and test this, and we'll see. I've got the computer set up. Let's just see how far off we are. But also, I wanted to be able to see how nasty this actually sounds. So first of all, let's just listen to the computer tone. And I'll set up the scope so you can actually see that. And hopefully that ends up looking like an actual square wave. Now, let's plug in and get the next one. And we got nothing. Why? Why are we getting nothing? That's plugged in. Well, let's double check. Let's go to another note, to one of the previous ones. That is working. That is somehow not working. What have I missed? It's entirely possible it's the chip. Alright, so I'm going to have to go away and come back after I've diagnosed the problem. Silly me. If you're going to use the mixing output to listen to things, you need to put the mixing resistor on your oscillator. I didn't put that particular resistor in. Now it's in. It should be working. So let's plug her in. And we'll set up the scope here because I want to see just how rough this looks, because there's one component missing, and that component will be key to getting a cleaner sound. So let's find out. That is just a regular tone that's been fixed. This is the new one, which actually isn't all that bad. You point that more towards the microphone. It's the capacitor, the decoupling capacitor. It's supposed to clean up the signal. So let's see. Doesn't seem to have much effect. So I could probably use a different capacitor. But now let's compare that to the computer generated tone that it should have been. That actually sounds like it's pretty close. Let's just go plug it in and find out. I can hear the warble. And I've That's without the capacitor. So actually, I don't want to tune it just yet. And I'm going to pick whichever capacitor seems to fit in there because I have a limited supply of capacitors, and this is junior. I still need to build the main keyboard, and I don't want to have to order up a whole bunch more capacitors and have to wait for everything. So let me go ahead and take care of the capacitor, and I'll come back. And I'm back. I played around with the capacitors that I've got just to try and figure some things out, things that I hadn't figured out before. And so what I've discovered is the capacitor, I've got plenty of capacitors for what I need for being able to build this and build the big keyboard. So I'm good there. Let me go ahead and, well, before I plug in, what I've discovered is ultimately the lower value capacitors don't have much of an effect on it. In fact, it even kind of looks like, at least at this particular frequency with this particular set of components, I almost don't need the decoupling capacitor, but I'm going to put it in anyway, just in case something else comes along to try and create interference. So I'll be doing that, but I discovered one unique little thing, which might be something I can use, I can explore in the future in terms of sound effects, things to change the frequencies or make interesting sounds. So I'll go ahead and plug this in, and we'll start swapping different capacitors in so you can see. It makes a little weird warble when it first comes up. Now this is, I should have put my glasses on. This is the 0.1 microfarad. And if you listen carefully, there won't be much of a change. Okay, maybe it did remove some overtones. That is probably the one that I'm going to go with. I've got the 10 microfarad that I was using originally for the first two. And plug that in. It actually drops the frequency a little bit, which could be a problem. I'm not sure. So I'm going to pull that one out. But what was really interesting was when I just said, okay, let's just go all the way to 1,000 microfarads, which is a millifarad. And this had a really interesting effect. And actually what I want to do first is I want to short it out to make sure there's no charge on it. So just stick it on a piece of metal there. At this rate, with this voltage, I'm not too worried about it generating sparks. But listen carefully. And I'm really curious to see what the scope is going to look like. Give me a second. And eventually it does settle into where it should be. But that was just really interesting. If you want every key to sound like a siren, high level, high capacity capacitors are probably the answer to that. So I'm going to go ahead and put in the 0.1. I'll solder it in, and then we'll come back and we'll try and tune this thing. Now I've got the capacitor in. Let's see how easy or hard this is going to be to tune. Remember, I've put the 1K back in. The previous two, I ended up going to a 5K because I didn't have enough adjustability. We're going to give this a shot. Maybe it's getting faster. Yeah, that's the right direction. What happened? It just suddenly dropped. Oh, no, I know what happened. Wrong file on the computer. Give me a second here. I was so close. I forget these are just 1 minute samples. So let's go back to the E. It might be just a hair off, but I'd say that's pretty close. Let me back this up. Let's see how... No, I can hear the beats. It's off again. I'd say that's pretty good. So, off with the computer, off with the sound. Yeah, it warbles a little, I think, when I'm shorting against things, but that sounds like I've got C, D, and E now done. So now it's just a matter of filling up the rest of this, and then we'll go back to tuning. I'll figure out the capacitors on my own, off camera, and we'll come back to it. See you in a moment. And despite a couple of hiccups, it's done. Also, one positive thing, my 2K ohm resistors came in. That's not the packaging they came in. I just repackaged them. Let me just sort of go over this because something that I've probably covered before, but it's worth covering again. The way this is set up is... There we go. I had a little trouble getting this off. The way this is set up is you've got R1 here, and then what I did was I took R2 and I broke it into 3 components. Actually, that's not the way to do that. 3 components. Something more like that. Now, this is not, there's actually other circuitry in here, but R1 is just a single resistor. R2, let's do that, is R2A, B, and C. C being down here at the bottom is these variable resistors, and that's where I was saying that the 2Ks came in just in time because I actually needed a 2K here. When I first started all of this, I put in a couple of 5Ks because my 1Ks weren't quite big enough. And when you get to a calculation point where it says that you need to adjust it somewhere around maybe 850 ohms, and you've got a 1K trim pot, if you happen to be below... If these two resistors happen to be below what you specify in designing it, in calculating, then you potentially end up in a place where that 850 is not going to be enough. That 850 then becomes like 1,100, and a 1,000 trim pot is not going to be enough to cover that. So I ended up going to the 5,000 trim pots, the 5K ohm trim pots, and that took care of my problem. But then it was at that point I realized I probably need some 2K trim pots, and so that's why I ordered those up. The other thing being, I realized, okay, if I specify that I need, say, a 1,000 ohm resistor here, but it ends up being 950, something like that. That affects the calculation for this resistor. And then when I do this resistor, say for instance, if it's supposed to be 22,000 and 4,700, and I pick a couple of resistors that end up coming up short of these. Usually they come up short. The interesting thing, I tested a lot of resistors while I was doing this, and I found that the majority of resistors that are not exactly what they say they are end up being lower rather than higher. Even though it says it's say a 5% tolerance, it doesn't. It means it could be within 5% below and 5% above, but it doesn't. It usually ends up being within the below area, and I think that's because they just test the resistor and decide which bracket it fits into. It's close to the 22,000. Okay, we'll call it a 22,000, and we'll say it's 5%. And with more rigorous testing, you can find the 1% resistors, but then you might end up with a bunch of them that are nowhere near 1%, and I think that's what ended up happening to me. It's what do you do if your resistor is nowhere within 5% or 10% of a standard resistor value? You just pretend it is, and you sell it that way. So that's what I'm running into with the resistors, I think. And so I'm just happy to have these. So now everything is set up. I'm going to do this the easier way. I'll get rid of this so I don't end up with it all over my arm while I'm working. Dry erase is nice, though. Okay, we'll get rid of these. Now I've got to set this up, and I'll set it up, and we'll come back, and we'll start tuning. Okay, we're set up now, and I'm going to plug in. I just want to verify that these are oscillating, that there's nothing wrong with the chips or something else, and then we can go from there. So these are all going to be a little bit rough, but we'll just run through all of them. Let's see. So this should be C. Okay, D. Oops. Let me try that again. D. E, F, G, A, B. Now, potentially I could have one more, but I only have the 7 keys. So that's something I'm going to have to decide what I want to do with this last oscillator and how I can sort of take advantage of the space that's already here. But there we go. We've got all of them functioning. That's good news. Now let's get down to actually tuning them. So let's see, we did C, D, and E already. So we need to go to F. Here comes the scope. And here comes the computer version. I hope that doesn't mean I'm too high. Alright, I've given it quite a few turns, and it doesn't seem like it's gotten any better, so I'm going to have to figure that one out. I'm going to go back the other direction. We'll see what happens. Alright, I'm going to have to come back to this one. And we'll have to go to the next one and just keep tuning. Okay, that should be a G. Okay, that's closer. Wow. Am I out of range again? I've gotten to a point where it's not getting any better. So I'm going to have to test the resistance on that one and move on to the next. Ooh, wow. These resistors are getting hot. I gotta figure that one out. Alright, I gotta switch this one. It's almost dead on, I think. That's hard to tell. Alright, last one. Okay, I think that's got that one. And okay, well, we've had some problems. Now, let me take a look at my spreadsheet to see what it says about frequencies. Because that was a little odd that was giving me trouble. Okay, there's the B, there's the A. Now the G, if I put a 1500, wow, those are getting hot. Ow. That's a new one for me. Didn't expect it to be dropping that much current, but I'm going to unplug the power and give them a rest. Let's hope that doesn't somehow come back to bite me. Famous last words. Let me get my multimeter. Now, according to my calculations, for the G, which would be this one here, which was, I think, the second one to give us trouble. For the G, we should have 1500. No, I actually had that at a 1000 ohm resistor for R1. And let me actually move this closer in frame here. It should have been 1000. I ended up changing it to 1500 because I was running out of 1K resistors. So I'm going to have to order up some more before we build the big one. But let's just see. I tried to pick the resistors to be as close to the actual stated value while I was putting this together. And so here is the 1500 R1. That's coming up at 1495. That's okay. Then we've got the should be 17,617 and a little for R2. Now I'm noticing this might not be fully soldered in, but let's see. From here to here I'm getting 14,890. That means I need 3K on my trimmer. That doesn't make sense. So let's see, this one, oh, there's your 1490. Somehow this resistor, 2.19, that was supposed to be a 2200, yeah. So how do I end up with 14.9? Oh, wait a minute, let me see. Is there a connection between these two? Oh, it goes this way, doesn't it? There we go. That's what I'm doing wrong. It's these 2 points for me to test it. Here, I should get a total. There we go. We're getting closer. 17.1K. I needed to be at 17.6. So I needed about 500. Yeah, 417, sorry. That's what I had calculated on that. Now, if I disconnect all of this and go underneath, that should be this one right here. Let's see what this is adjusted to. 0.985, I'm too high by quite a bit. Now the real question is, if I try to turn this, does that change? So this is the troubleshooting that I need to do to figure some of these things out. I'm going to go changing... Oops, wrong one. Crap. I think I just detuned one that actually was giving me trouble anyway, but I'll have to retune it. The fact that both of them are sticking up just makes it slightly more confusing. So I'm giving it several turns in the clockwise direction there. Let's see if that results in a change. .985. I may have a dud of a variable resistor here. That is an interesting... Unless, actually, no. That was clockwise. This thing will just keep turning. It doesn't actually stop. So, oops, I'll get the right one here. So now let's go counterclock by a few more than the first several. And see if that reduces it, because 0.985 or 985 ohms, that's 0.985K. Let's see if that helps the situation. .635. All right, so I need to drop that one a little bit further. We'll give that a test, and then I'm going to go through the rest of the oscillators and figure out whether that actually, I have any duds, any parts I have to swap out. Usually you don't get duds with electronic components, but never say never. It's always possible. Okay, that's hooked up. Now we need the speaker. So that was C, D, E, F, that was G. Let me get that up and running. And there it is. Nope. There's G. Should pop up any minute now. I got to jump from the positive to C, D, E, F, G. All right, I'm going to have to dig into this a little bit more on my own, and I'll be right back. Okay, I'm back, and the results are in. I don't think it's... I'm not going to put this failure on myself, and I'm not going to put the failure on the manufacturers of the various parts, or for that matter, on the oscilloscope. But ultimately what I'm running into, let's see, number one, let's just talk about the oscilloscope, because I brought it out a couple of times and then I haven't actually showed you it working. I could turn it on just so you could see. This is not an endorsement, but it's also not a criticism. This particular unit, which was not that expensive, ultimately gives me results. How can I say this? There's a frequency thing here. I'll try and blow that up in post so you can kind of see the numbers running here. But The frequency is measured in kilohertz. And in this particular case, these tones that I'm trying to generate are at about a third of a kilohertz. So 1 or 2 hertz, 1 or 2 cycles per second is not going to make... It is going to make a difference, but it's not going to make a difference. I don't know that the human ear can necessarily distinguish that well between, say, an A440 and an A439. 440 cycles per second or hertz, or 439. That's 1 apart, even 2 apart. Now this one, the accuracy on it seems to be about plus or minus 2 hertz, which is right where I'm talking about. So trying to measure with this is not really... It's giving me a general ballpark and telling me if I'm anywhere near where I need to be, and that's useful, but it's not great for tuning. So I won't be able to use this for that, but I'll be able to use it to look at the waveforms and make sure that they're reasonably clean, which I have done, and they are reasonably clean. They're not perfectly clean. I could probably run it through some filters and clean up the signals, but ultimately I'm going to start with a square wave and probably filter down to a triangle wave or even to a sine wave, but that'll all be theory and stuff we'll talk about later. So that's the oscilloscope. Secondly, I've got the results that I wrote down here, which are showing the really key thing is the F, G, the A, and the B that I put together in the last little bit. And so the B turned out to tune just about perfectly. It came in within a hertz. I'm happy with that. The A, I kept turning the trim pot, and I could not get it any lower than 461 hertz when I need a 440. So that's a fail, and I need to figure out a way. I think what I might be able to do is swap out the capacitor, because I started putting in different capacitors after that experiment that I did earlier that seemed to indicate that it didn't really matter what the value of the capacitor was. I think if I raise the value of the capacitor, it'll drop it a little bit, and then I might be able to pull it within range without having to desolder the trim pots, which is a real pain to do. The G is supposed to be at 391.99, give or take, and I was coming in at about 393. I originally called that a failure, but upon reevaluation, realizing that's pretty close. So I don't know if I was playing something that anybody would really know the difference between my G and a true G, or at least a true G with this particular tuning. The F started at, or is supposed to be at 349.23, I think that is. I can't read my own writing. And I started at 364 and started going back down, because the other problem that's happening is that I'm hooking everything up, and then I get confused because I've got to move little wires around and then start tuning on one of these, and I'm setting up to listen to one and tuning another, which is screwing up the tuning that I had already gotten set. So these are pretty much where they are right now, and I'll go back and do another pass to make sure everything is tuned in. But basically, I could not get below 363 here. So again, I'll probably change out the capacitor and hope that'll help me drop by a little bit and pull me within range. Otherwise, my other choice, because even with that one, I think that's a 5K, and I can't remember at this point. Having to swap out these trim pots is a real pain. Plus, then they become almost useless after you pull the old one out. I'd rather have something I could reuse, and I'd rather just be close on this, because this is just junior. This is not the final product. So for the final product, what I'm thinking here, let me get rid of all of this now that we've documented it. What I'm thinking, if you go back to the R1, R2 thing that I was showing just a bit ago, is you've got your R2 is 1, 2, 3 resistors, And I think what I need to do is when I'm doing my calculations, I need to consider the variable resistor here, the trim pot, to land in the middle of the range. So let's say if I'm trying to get 30,000 ohms, and this first one is 22,000, and this next one, say, is 7,500. That's going to put me at 29,500. So this, I need 500 more to get to 30,000. So the midpoint of this variable resistor should be the 500. So in other words, this should be a 1K pot. But if I end up, in a different scenario and I end up at 1,000, then I probably need a 2K pot. And if I end up at 1,500, then I'll probably end up jumping to a 5K pot, because I don't know if I want to go buying every conceivable value of trim pot. So that's where we are on all of this. I'm going to get the rest of this all tuned up the best I can. And the next thing I'm going to do is actually probably remove this header here and wire Junior in permanently, and then figure out how I can do a better job of connecting in the power and getting the speaker hooked up. Just better ways of getting it all done so that I can carry it around and not always have to set it up with an external power source like this and all the rest of that. Just within this board here. I don't want to create new boards and all the rest of that. This is just Junior. I'm trying to get that set up, and it will teach me things as far as the main product. So Junior has been incredibly useful in terms of teaching me what I've done right and what I've done wrong in terms of my design, and allowing me to figure out what changes I need to make. So at this point, I was going to do something else, but this video is probably getting long enough. So next week, hopefully you will see this all put together, and we'll talk about the next step, even though the parts may come in this coming week. And if they do, it might be a little too tight to try and release a video building the main keyboard. So my apologies for the further delays, but this is the development process, folks. This is what happens when you're trying to create something this complicated, is you're going to have delays. If you're looking for something that's going to move along a little bit faster, I would check out Freeform Friday. The idea there is each week I'm building some project. I am working a lot on the Christmas lights, DIY Christmas lights. If you were to create your own Christmas lights, you want to create your own colors, your own brightness, your own animations, that stuff will all eventually be possible. This year, because I'm running up against time, it's the beginning of November as I record this. This year, I probably will only be able to do simple, solid colors, and then throughout the year, we can look at adding animation to it and stuff like that. But I just want to get the system figured out and up and running there, and hopefully I'll have that figured out in the next couple of weeks. So, and that should be in enough time for you to be able to order parts if you want to do that. Also, I mean, I've got the wallflower kit. Maybe what I'll do is, maybe I'll do a bonus video this week, and I'll just build a kit, a random kit that I happen to have lying around that I haven't gotten to yet. That's not my own. It's already been developed. And we'll go from there. So thank you for sticking it through with me here, and thanks so much for watching. Take care of yourselves. See you on the next one. Keyboard Junior is alive.